Hi guys, happy Monday. Another week of online learning. Last week and even before the shutdown, we were able to look at different factoring techniques. Now this week we will focus on combining all those techniques together to completely factor certain polynomials. So our goal for this week is to answer the question, how can we factor a polynomial completely? In the PDF file that I sent you for this week, there was a graphic organizer that looks like this. This will be very helpful because it gives you a step-by-step procedure on how to factor certain polynomials. So let me start with an example. In your PDF file, you're given 14 polynomials for today, and the first one is 35m to the fourth minus 375m cubed plus 250m squared. So in your head, you don't have to write this step down. You have to find the greatest common factor of the constant and the variables. So as you can see here, the GCF is 5m squared. So what are we going to do with the 5m squared? We're going to divide each term by the greatest common factor. So if you divide these by 5m squared, you will get 7m squared minus 75m plus 50m squared. And then after that, you have to determine by using your graphic organizer what next method you will use. How? You have to count the number of terms. And since there are 3 terms here, you have to either do a perfect square trinomial or an X method. We know that this is not a perfect square trinomial because 7 and 50 are not perfect squares. So hang on. When I divide 50m squared by m squared, I forgot to delete this one. So this should be just 50. There you go. Okay, so now, since there are 3 terms, I can use the x method. So the linear term is negative 75, and the constant is 50 times the quadratic term, which is 7. So 50 times 7 is 350. After that, I have to find 2 numbers by trial and error. So if I multiply negative 70 times negative 5, I get 350. And then if I add them together, I get negative 75. So where did the 7 come from? I had to divide by 7 because the quadratic term has a coefficient more than 1. Okay, so now negative 70 over 7 is actually equal to negative 10. So if you use negative 10 as a factor, it will be m minus 10. This one does not reduce or cannot be reduced anymore. It is in its simplest form. So you write the denominator before the variable. It's going to be 7m minus 5. However, there are instances when it's not a trinomial. Let's say, for example, here, you're given 25mp squared minus 45mp, and the GCF is 5mp. So if you divide the given polynomial by the GCF, you will get 5mp times the quantity 5p minus 9. Okay, count the number of terms, right? It has 2 terms only. So if I go to the left-hand side, I will either do a difference of 2 squares, okay, which is not possible because 5 is not a perfect square, or I can take out another GCF if there's something that I missed out on. But 5 and 9 are relatively prime already, so they don't have a greatest common factor anymore. That's why the final answer is 5mp times 5p minus 9. Okay, so there you go. I do hope that you follow this graphic organizer to figure out what's the next step in factoring. If everything else, if you've tried everything else and you think that it's not possible to factor it, then it means the polynomial is prime or it's not factorable. Yeah, I hope that helps a little bit on our topic for this week, which is factoring polynomials completely. I look forward to looking at your responses online. Have a good day.